Use an infinite series to determine A, there it is, and B from the figure below. Oh, what's X? Oh, X is 0.75. When would they put the number in there? Oh, because it's squared. Oh, and this one's cubed. Oh, so this looks like this distance here is 0.75, and this distance here is 0.75, and this one's x squared. Oh, what's x? 0.75 squared. Oh, is that number? Okay. Huh. Okay. And we want to determine the distance a and b. So, well, I know this is one. I have to figure out. Okay. Okay, let's write down what a is equal to. So a is equal to 1 plus x. I'm going to keep an x because I can see why they did it, because I want to try to keep these, instead of having these numbers here. So x squared plus x cubed, and it looks like this thing goes on forever. So x to the 4 plus dot 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 dot. Okay, and what's b equal to? B is equal to x plus x squared plus, oh, it keeps on going on forever. Oh, this looks like they're the same thing. Well, I think I can put this together actually. 1 and 2, so I'm going to substitute 2 into 1. Okay, so if I put all that in there, I'm going to get a equals 1 plus b. Well, that makes it a little easier, so I only need to solve for one of them. If I solve for b, I'll get a. Okay, now I need to make an infinite series. So let's put down the numbers now. Let's just see the numbers for a second, okay? So let's just substitute numbers. Sub numbers, okay? So let's do the x. X was 0.75, and the next one was x squared, which is 0.5625, and then we have x cubed, which is going to be 0.421875. These are big numbers. Okay, and now we need to figure out if it's a geometric or arithmetic sequence. So let's try arithmetic. So k is equal to, let's try these differences, 0.421875 minus 0.5625. And that difference will be 0.5625, negative 0.14625. And the other difference of 0.5625 minus 0.75, 0.5625 minus 0.75 is equal, whoa, what happened? Is equal to negative 0.1875. Okay, so it's not arithmetic. They're not the same numbers, so it's not arithmetic. Okay, let's try geometric. So r is equal to a to the n plus 1 over a to the n. This one was equal to a to the n plus 1 minus a to the n. So let's try ratio. And the ratio here, a to the n plus 1, let's try this number. So 0.421875 divided by 0.5625. And that gives me 0.421875 divided by 0.5625 equals 0.75. Oh, I think I'm going to get the same number for the first one too. 0.5625 divided by 0.75 is equal to, I bet you that is going to be, yeah, 0.75. Okay, so this is a geometric series. Yes, this is a geometric series. Okay, for a geometric series, what are we looking for? We're looking for the infinite series. We want to add all these numbers up. So we're looking for the, not the value, but we're looking for the sum. So, and the value actually would be 0 if it's a converging series. So we're always looking for the sum for an infinite series. For an infinite series, because the infinite one is going to be 0. So the sum is equal to a1, 1 minus r to the n, all over 1 minus r. Okay. Is our ratio is smaller than 1? Yes. So this series here, 1, well, 0.75, let's put that in ratio form. 0.75 is 3 quarter, which is smaller than 1. And that will give us, that will go to 0 as n goes to infinity. That goes to 0 as as n goes to infinity. Okay, because the ratio is smaller than 1. So we can just plug in the numbers. So Sn is equal to a1, which is a1. There's a1. So it's going to be equal to x over 1 minus x over 0.75. So let's plug in the number. 0.75 all over 1 minus 0.75. Because the ratio here was 0.75, which was x. So that's why I write down 1 over x. This is the general equation for this solution. And I guess that's why they gave x, because you could do this for anyone. X 0.2, and there's the solution right there. So here's the number for this one. For x equals 0.75 divided by 1 minus 0.75, bracket close, equals 3. Okay, so that's the sum of this one, which is equal to b. So b is equal to 3, and therefore a is equal to 1 plus 4.